What's up, guys? Danny here with Danny's Motorworks. On this video, I'm going to be going over, I got a 1980 Kawasaki KZ440. This is actually my personal bike, and I've been looking at getting rid of the point system on it, just to maybe get some increased reliability. There's not really a company out there that makes a very good points replacement ignition system for these bikes. I looked at going with the electronic ignition systems, but for the price of $400 or $500, kind of hard to justify, considering that's about probably half the cost of the entire bike. So I kind of came up with a solution here that takes some piece parts together and can actually put a Dynatek Dyna-S ignition system in place of the breaker points. So just kind of an overview of what we're going to be doing here. I have a Dyna-S ignition system here. This is the Dyna DS6-1 ignition system. These can be had online for about $125, this setup here. And then from there, I actually ended up contacting Dynatek and getting a -3 rotor for a Kawasaki. This is for like a KZ900 or 1000 4-cylinder. But this ignition rotor will work with the stock advancer on the twin-cylinder KZs. And also, this wouldn't really be required, but this is what I ended up doing. I ended up just purchasing a separate points plate, just so I could modify this plate and leave the stock plate intact with the breaker points and the condenser. Not really needed for this, because obviously you can remove these pieces from your points plate and do the modifications to that. But I just decided to buy a separate one of these and make the modifications to this one. So just to get started here, obviously I have the gas tank removed. I removed both spark plugs and also the ignition cover. So the next step here, I'm going to have to reposition the camera, but we're going to want to get the engine up on TDC on the right hand cylinder here. So I will just remove these 3 Phillips screws here, just lay this points plate off to the side, and then I can get a better view of the timing marks in here for you guys. A little bit closer view here. Got the 3 Phillips screws removed from the points plate here. This just simply pulls straight out. Just lay that down off to the side for now. These engines actually rotate counterclockwise, so we're going to want to rotate what would kind of seem backwards, but the crank rotates counterclockwise. Now I kind of got it mostly set up here just for the video purposes, but best way to do this is just keep rotating the crankshaft. This is a 17mm nut here to rotate the crank. Now I always just kind of put finger over the spark plug hole, so then as you're rotating it, you can feel and hear the air coming out of this cylinder. That verifies that you're coming up on the compression stroke on this cylinder. So as I come up here, I can feel and hear the compression coming out of this cylinder. Now, with this being a wasted spark system, this isn't really extremely important that this is on TDC of the compression, because either way it's going to be on TDC with this cylinder, whether it's on valve overlap or compression stroke. But it's always just a good practice just to do it based on TDC of the compression stroke. And then from here, I'm actually going to grab the camera here and let me move this into a little bit better spot. So you can see here the timing marks on the advancer unit. Let's see if I can get in there and get the light. So you can see this F with the line. That's the mark that we're going for. That's going to be the static timing mark that we're going to set with the engine just not running. You can see there's a couple marks over here. Not sure if you can see that. So that's actually the advance marks when the engine's running at high RPM. So that would actually be set with the timing light with the engine running probably 3,000–4,000 RPM. So we're going for this F here, and then actually you'll see after that that there's a T. with a line at it. That's actually true TDC of this right-hand cylinder. So we need to rotate it a little bit more so we line up that F with the timing mark located here. And we're going to rotate this so the line on the F matches the line. There we go. A little bit of slop in there, but for this it'll be okay. Grab the camera here again, and as you can hopefully see here, you have the F mark here lined up with the line on the crankcase. So now we got this right hand side in time. Next step is going to be to remove the center bolt. So this nut on the outside, the 17 millimeter, that's for turning the crankshaft over. In order to pull this advancer unit out, we need to pull this bolt out here, and then this advancer unit will come out. So I'll loosen that up now, and actually I already have it loosened up. So spin this bolt out here. That bolt comes out. You'll see this nut comes off with that, and it has a couple notches in it that actually contact there. So this is basically just there in order to rotate the engine over without actually loosening up the advancer. And then here you'll see the centerpiece should slide out. So this is actually the points cam, so this is what opens and closes the points on the stock system. Just for reference here, this is the number 3 rotor from Dynatek. That slides right on the stock advancer, interfaces with our flyweights here for the ignition advance, and that's what we're going to be using for the Dyna-S ignition system. Now at this time, obviously would be a good idea, you can remove this advancer and you can pull these E-clips off here, you know, clean up those posts, lubricate those pivot points so that these flyweights spin freely. These feel pretty good, but as long as it's out, I'm probably going to do it on this one. At this point, I just affixed the extra points plate that I have here, just to give an overview of what the general direction of this modification is going to go. Now we have the Dyna-S ignition system here. This is actually a used piece, but this is from a Harley-Davidson, so this piece actually is not going to be used. So what the plan is here is if you remove these 2 small Allen screws, this is a 5/32 Allen head. This pickup actually comes right off the plate. So after this plate's been modified to fit the Dyna rotor, we're basically going to fix this pickup to the plate in the proper orientation to pick up the magnetic pickup from the rotor to fire our coil. So we're basically using the stock KZ plate, mounting the single Dyna-S pickup to the plate, and then using the Dyna rotor here with the stock advancer. And we're back after modifying the points plate. Just to give an overview of what ended up doing is there is this kind of standoff right here that holds this felt pad. That needs to come off. Actually, notice here this one has a Phillips screw in it. The points plate that I had purchased did not have that, so I actually had to take a 4.5-inch cutoff wheel, and I just cut that piece off to make it flush. And then this center opening needs to be opened up to 1 1/8 in order to fit the number 3 Dyna rotor through the points plate. Now, I ended up doing it on a mill with a 1-inch end mill, and found center and just open that up enough, or you could do it with 1 1/8" drill bit, die grinder, what have you. But either way, that center needs to be opened up to allow this to stick through it. Then at this time, we can put the stock advancer back in. If you notice, there's a little keyway cut in here. That engages that dowel pin in there. So put that into position. You'll feel it kind of drop into place, lock in. Easy as that. Then we can install our Dyna rotor onto the plates, making sure that the notches line up with the flyweights. Might have to open them up. There we go. We'll notice that as the weights open, it rotates the rotor for our ignition advance. And then we put our slotted nut back into position. Put our center bolt in here. Hold this with our 17. It's a little bit tight here, but I think we'll be able to do it. And snug that center bolt up. Then now we should be able to fix our points plate into position just like so. So now we have the Dyna rotor sticking out past the points plate. The next step here will be to get our pickup mounted into position that we removed in the previous step. We're going to have to figure out the exact mounting location of it, and we're going to have to drill and tap these 440 machine screws and mount that into position on the stock plate. Now I did notice here, actually, just as I'm installing, that this rotor has quite a bit of in and out slop. So keep that in mind as you do this. Looks like I'm going to have to add a washer or shim or something to take up some of this slop, because we don't want this in here bouncing around like this. But for the time being, I'll be able to carry on with the install. Alright, I'm just going to hold the camera here and do a quick walk around and wiring this up. So we have our Dyna pickup here. Just ran the wires down along the frame rail. This is all just kind of temporary until I get it. I just want to verify operation first, but just where the stock wiring went, move around to the other side of the machine. Wire comes up here, and on these Dyna-S ignitions we have to supply them with 12 volts. So we have our yellow and red wire here coming from the machine. I just did a butt splice into that and double tapped the white wire going to the Dyna ignition, and then this yellow wire continues down to one of the terminals on the coil, and then the blue wire from the Dyna ignition comes up and goes directly to the other terminal on the coil. Polarity on this doesn't matter. I just did it in this fashion because that's just how it worked out. So yeah, you need to supply 12 volts to the Dyna ignition. This yellow and red wire is what originally fed the coil. So I just picked up 12 volts positive there. That goes down to the ignition. And then the blue wire just comes up and connects to the other side of the coil here. Kind of got a janky setup going here, but this is the way we do it. So I have the coil hooked up, like I said. I have this is just a 12 volt ice pick light. You need to hook up the alligator clip to this to the blue wire on the coil coming from the Dyna ignition. So that's just piggybacking off of the blue wire mounted to the coil. I just laid the ice pick tester in the spark plug hole just so I can see it, because we're actually going to be using this light to set our timing. I'm going to have to set the camera down to do this, but I'll just hold it here. And basically what we're going to do is we're going to turn the key on, and we're going to just hold this here manually, and then we're actually going to rotate this. There's a green line green dot that I marked there, that's where the actual magnet is on the rotor. So we're basically going to start with this pickup here and then slowly roll it around the radius coming from this direction, going against the crankshaft rotation. And then as soon as we see that test light come on, that's when we know that that's when we're starting to come into the window of time. And then once it's there, I'm going to hold it there and then mark these slots. So I'm going to turn the key on for the machine. We'll see test light came on. So that means we have power there. And then once I apply our pickup, that light's going to go off. And then now we'll see here that as I roll this around and it comes into the pickup, into the magnet on the rotor, we're going to see our test light illuminate. So I'm just going to kind of do that a couple times. And like I said, you want to roll into it from this side because that's capturing the leading edge of that window for the timing. And then obviously you want to make sure that you're not actually touching the rotor. It actually probably will work good. Hold it up against the rotor and then just back away from it slightly. And then obviously when we're doing this, forgot to mention, I do have the bolts here. I have the plate perfectly centered in the bolts. So when I mount this, I can always fine tune this whole plate, whichever direction I need to go. Okay, I'm going to call that good right there. I'm going to mark my locations for my screws. There. Okay, so now at this point, I'm going to take this plate off, center punch those two marks that I got, and then drill and tap those for a 440 machine screw. Alright, here we are. So, got the holes drilled and tapped. Like I said, it was a number 43 tap drill, and then a 440 machine screw tap. And it actually worked out really well. Got my two screws installed. I also drilled and tapped for the little clamp here. And then once I button this up, I'll probably put some P-clamps or something on either one or two of these just to keep the wire away from the rotor. Again, I have the points plate pretty much set at the center position, and then I have these screws that are holding the pickup loose, and then I can rotate the pickup until the light comes on, and then I can lock this down, and then all of my timing adjustment can be made with the larger Phillips screws on the outside. So let's get started here. So I'm going to back it up as far as I can this way, and then I want to creep up to it that way until our light comes on. Boom, right there. So then snug our 440 machine screws down. Obviously 440 is a very small thread, so on these, I mean nothing more than fingertip tight on those. And these screws are already tight, so then also double checking that you're still on your F timing mark through the window here. I'm actually really happy with that. The spacing looks pretty good on that from that rotor, so I think next step we might try to fire this beast up. Alright, that was actually very first fire, and I'm very happy with that. I'm going to turn off my exhaust fan here and give some closing statements here. Hang tight. Alright, there you have it. Like I said at the beginning of the video, kind of set out to do this to find a different option for putting better ignition on these twin cylinder KZs. Like I said, there's a lot of options for the 4 cylinders, and there's also electronic options for these, which are great ignition systems, but again, just had a hard time justifying spending $400 or $500 on a machine that, again, like I said earlier, is worth it's probably half the price of the bike. So just kind of a quick rundown. I'll put links to this stuff in the description as well. Again, so came into it with a Dyna-S single pickup ignition, the DS6-1, actually for a Harley Davidson. Comes in right around at $125, and then sourced out the number 3 rotor from Dynatek. With shipping, that came out to $31. Third thing I forgot to mention before, with this ignition system, you need at least a minimum of a 3 ohm ignition coil. A lot of these stock coils are substantially less than that, so you will have to purchase at least a 3 ohm ignition coil. This is actually a 4 ohm that's on the bike here. I believe 4-into-1 has a pretty good coil here. Shipped to your door is about $35 for a 4 ohm coil, and then just a couple of these 90-degree NGK caps. Those are $2-3 a piece, not a big deal. So we're talking about all in on this ignition system, buying everything new. You know, you're at about maybe just shy of $200 or right around $200. Still not the cheapest date. A little bit of time involved, obviously, but at least getting rid of the point system and switching it over to a little bit more reliable one. The other advantage to this system is the electronic systems. Once the battery voltage falls below a certain range, usually around 11.5 or 12 volts, they'll just shut off completely, and you're just, unless you have a jump pack, you're kind of stranded. The nice thing about these systems is the coil will still fire with these systems at a very low battery voltage, which on these older bikes, that can be a pretty big benefit considering the charging systems are kind of iffy at best. You might be able to get away with, bump starting the bike or something like that. So, I guess this was the first video. Might try to start doing more of these here and there as stuff like this comes up. Let me know what you think. Thank you. Cheers.